Hello everyone. In today's video, let's work on a question related to trigonometric identities. Here comes the question. Let x and y be acute angles such that sin x squared plus sin y squared equals sin x plus y. Prove that x plus y equals pi over 2. The right side of this equation is sin x plus y, which can be expanded to sin x times cosine y plus cosine x times sin y. Then I'm going to move the ones with common factors to the same sides. Then the equation becomes sin x squared minus sin x cosine y equals cosine x sin y minus sin y squared. On both sides, the common factors are factored out. Then the equation becomes sin x times sin x minus cosine y equals sin y times cosine x minus sin y. Note the two terms in the brackets, sin x minus cosine y and cosine x minus sin y. It reminds me of the sum to product formulas. However, in the formulas, the format is sin alpha minus sin beta and cosine alpha minus cosine beta. So we need to change the cosine y to sin something and sin y to cosine something. Well, we can do a simple substitution to achieve this. The substitution is let z be pi over 2 minus y. Then, of course, since y is a acute number, z is also an acute number. And more importantly, cosine y becomes sin z and sin y becomes cosine z. Now, this equation becomes sin x times sin x minus sin z equals cosine z times cosine x minus cosine z. Now we can apply the sum to product formulas. Then the equation becomes 2 times sin x times cosine x plus z over 2 times sin x minus z over 2 equals minus 2 cosine z times sin x plus z over 2 sin x minus z over 2. Since both sides have 2, they can be cancelled out. I note that in this new equation, both sides have a common item sin x minus z over 2. Of course, when this common item is 0, then the equation holds. This is a case number 1. Sin x minus z over 2 equals 0. Since x and z are both acute angles, then x minus z over 2 is in between minus pi over 4 and pi over 4. And since sine of this angle equals 0, then that means this angle x minus z over 2 equals 0, which means x is equal to z. And since z equals 2 pi over 2 minus y, then we get x plus y equals pi over 2, which is the one that we need to prove. This is for case number 1. Then, now let's consider another scenario. This common term is not equal to 0. And in this scenario, it can be cancelled from both sides. Then the equation becomes sin x times cosine x plus z over 2 equals minus cosine z times sin x plus z over 2. I notice there's a negative sign here, which seems strange. because since x and z, they are all acute numbers, that means sine x is larger than 0 and cosine z is also larger than 0. And on the other side, the average of x and z, x plus z over 2, of course, is also an acute angle. That means cosine x plus z over 2 is also larger than 0, and sine x plus z over 2 is larger than 0 too. That means in equation 2, all the 4 terms, they are positive. But there is a negative sign here that leads to the conclusion that a positive number is equal to a negative number. And there is a contradiction here. That means case number 2 does not exist. Therefore, in summary, the only conclusion that we can make is x plus y equals pi over 2. And this problem gets solved. Thank you.